we're going to look at a specific type of differential equation called a separable equation. So a separable equation is a first order differential equation. So first order meaning that we only have a first derivative here. So no second or third or other type of derivatives. So we just have a first derivative, and it's said to be separable or to have separable variables if it can be written in the form dy dx is equal to g of x times f of y. So in other words, we have some sort of function of x times a function of y. All right, so let's look at these numbers 1 through 6 and see if we can figure out which ones are separable and which ones are not. Right, so number 1, what I essentially want to do here is try to solve for dy dx or y prime. So I'll start by adding that 9y squared over to the other side. So what I get then of y prime is equal to 9y squared times 1 over x. So I have a function in x and then a function in y, and I have them separate but multiplied together. So yes, this one is separable. Number 2 has already been solved for dy dx, but I have y plus sine x. So I do have two separate functions. I do have a function of x and a function of y, but they're being added, not multiplied. So no, this one is not separable. Okay, and why don't you see if you can try the other 4 on your own? So go ahead and pause the video. Okay, so hopefully you went ahead and gave that a try, but let's go through the rest of these and see if we came to similar conclusions. So number 3 is already written as y prime or dy dx. But here I have x squared plus y squared. So again, I do have a separation of the x squared piece and the y squared piece, which is good. But it's got addition going on here. So this one is not separable. Okay, number 4. So I definitely want to make sure I get that y prime by itself so I can set it up into this form of dy dx equals this. If I do that, I get y prime is equal to e to the 3y. And when I divide this over, I'm going to try and group the things that have x together and the things that have y together. So when I do that, I'll have a sine x divided by the square root of 4 minus x squared. So it looks like I have this piece that's entirely in x. I have this piece that's entirely in y. So that would make this one separable. Okay. Number 5. So number 5, this one's a little tricky here. So I have dy dx is equal to 9 minus y squared. Okay. I don't have a function of x here, and so this is what makes this one a little bit interesting. I can definitely put parentheses around here, and then I can multiply it by 1. Okay. So here I have a function in y, and here I can claim that that's a function in x. So this is actually separable here. It's just kind of flying under the radar in disguise. Okay. So the difference between this one and this one, although they both have an addition subtraction going on, this one's addition subtraction is using an x and a y, whereas this one only has a y and a constant, and the constant can kind of be assigned anywhere. So in this case, I grouped it with the y squared to make it one function, and then added that 1 on there. Okay, and then number 6 is more of an algebra problem, so let's take a look at that. This is really y squared e to the 3x e to the 4y. So can we write that way? So what I have is dy dx is equal to, and I'll group the things with y and the things with x. So I have y squared e to the 4y. Well, those are all pieces with y times e to the 3x. So those are all pieces with x. And so yes, that one is also separable as well. So hopefully that helps. I know your first web work problem and your first homework problem are just identifying whether the given equations are separable or not.